This is AS Module 2, a paper from June 08. This is question 2, which focuses on lenses. Define the principal focus of a converging lens. This is point through which all rays parallel to the principal axis converge after passing through the lens. There are two marks for that. One is for identifying the converging idea, and the other is that it must be parallel to the principal axis. It's not just parallel rays, it's those which are parallel to the principal axis. To find the focal length then is the distance between the principal focus and the optical centre of the lens, for 1 mark. Very straightforward, that one. Part B then. A converging lens is used to form a virtual magnified image. So we're expecting it to be in the left hand side of the lens, or the same side as the object, and we're expecting it to be larger than the object and virtual. Figure 2.1 shows the position of the lens on the principal axis. The points F and F' are the principal foci. The points 2F and 2F' are twice as far from the lens as are F and F'. So we have a diagram that should look familiar to us. Mark clearly in figure 2.1 a possible position of a small upright object, OA, placed to form a virtual magnified image. So we want small and upright, and it has to be labelled as OA, placed to form a virtual magnified image. Well, if we want a magnified image with a converging lens, it must be placed between F and the lens. We'll keep it small and we label it as OA for 1 mark. Now for part 2, on figure 2.1 again, complete the ray diagram to show how the image of OA is formed. We need to label it IY and show a suitable position of the eye. So we have a ray diagram, label correctly, and identify the position of the eye. Okay, we always draw at least 2 rays, and if we draw one parallel to the principal axis, it converges through the principal focus. And we know we're going to have a magnified virtual image, so we can continue this as a dotted line behind the lens. As soon as we remove a ruler, we put the arrows in case we forget. And then a ray from the same point on the top of the object through the optical centre. And it passes through undeviated. And again, we'll continue this behind the lens because we know we're trying to get a virtual image that's magnified, and put a ray, an arrow on the ray, and then we can locate the position of the image where the 2 virtual rays meet, and it must be labelled IY according to the question. And the final part of that question is to identify a position for the eye, and the eye should be drawn where the rays point towards, so that the light from the object enters the eye, so we then see the magnified image. So the marks for that question, there are 3 marks. There is 1 mark for this ray, a mark for this ray, and the final mark is for the position of the eye in that question. Moving on to part C of the question, and it tells us the focal length of a converging lens used to form such an image that we've just drawn, the virtual magnified, the focal length is 10 centimetres. Calculate how far away from the lens, an object must be placed in order to form a virtual image which is 6 times larger than the object. So the only information we have is the focal length, and the magnification is 6, and we want to find how far an object must be placed. In other words, we want to find u. So given that we know the magnification, m is equal to v over u, we know very little other than that, apart from the fact that the image is 6 times larger. So that's 6u over u, if you like. Or you could say that 6 is equal to v over u, so v is equal to 6u. And we can substitute that in, but we must remember first off that it's a virtual image. So the image will be negative, so it will be minus 6 over u, because the magnification then is virtual. So we have v equals minus 6 over u, which we can then substitute into the lens law equation. Lens law is 1 over f equals 1 over u plus 1 over v. So 1 over 10 is equal to 1 over u plus 1 over minus 6u. When we rearrange that, we eventually get to the point where u is 8.3 centimetres. To show the rearranging of that, continue this over here. 1 over 10 is equal to 6 over 6u minus 1 over 6u. So 1 over 10 is equal to 5 over 6u. Now if I turn both of those upside down, I can say that 10 is equal to 6u over 5, and when I recalculate that then, I find that u is 8.3 centimetres. And then calculate the image distance from the lens. Well, if we look up above here, we have that v is equal to minus 6u, and we can simply use that. So it's minus 6 times 8.3, which gives us an answer of minus 49.8. Now you don't necessarily have to have the minus in this answer. The mark scheme will allow you to simply have the 49.8. In the previous part of the question, substituting correctly into the magnification gets you a mark, rearranging it gets you the second mark, substituting that into the lens law gets you the third mark, and then the final fourth mark is for the answer only. So if you're not confident about working with all this fraction work, you're really only losing 1 mark. You're getting 3 marks for the physics and 1 for the final mathematical rearrangement. So to summarise that question then, we defined the principal focus of a converging lens and the focal lengths. We then drew a ray diagram to locate a virtual magnified image using a converging lens. And then for that lens, we calculated using the magnification and focal length, we were able to calculate an object distance and therefore calculate an image distance.